All right, welcome back. So I was away for a while, but I'm back now. Let's take a look at the last video that I posted. Yeah, so the last video was the self-managed network video. We can see I didn't do a Hugging Face Agents course video for 10 days. And part of the reason, in fact, the only reason for that, the main reason for that, is that you have to pay for inference in order for your agents to have enough intellect to use the tools. And I ran out of inference. So I'm going to I'm going to show that because that's important for people to know. It's hard to know what you're paying for and what you're not if you just kind of go, uh, or it's hard to know what you get for free and what you have to pay for unless you understand the pricing. So there's a pricing tab in the upper right hand corner, and there's various tiers of pricing. There's the free tier that they're always going to have available forever. The pro account for $9 a month. There's Spaces hardware where you can it's almost like an AWS sort of uh, compute, sort of like EC2. Uh, well, it's more like Google Colab, where you can pay for um, optimized hardware, and that starts at $0 an hour. So there's like a free to use hardware you can use, but or you can pay for higher ones. And then the final one is the one that I ran out of. It is inference endpoints, deploying models on a fully managed infrastructure. So this is a little bit like hosting. So you have an endpoint for your model to run. Um, so you have to pay for that. It's uh, yeah. So this is like essentially hosting your model. It's not hosting a website. It's kind of like hosting your model, and that's different than powering up your model. So you have to host your model, and then you have to give your model power. So you do that by paying to have it hosted, which is an inference endpoint, and then you can pay to give it high level abilities by giving it more optimized hardware. So we can look in more detail if we click into any of these. So with the Pro account for $9 a month, you do get free credits to use for inference, and you get more advanced hardware. So you can definitely do some uh, rapid development and prototyping with the Pro account that actually has a little bit of meat on the bone, so to speak. Um, Even with the free tier, you can certainly take these classes and get quite far. Um, but when it comes to really creating products that are developed enough to sell, to become minimally viable, to start getting in money, you probably will have to spend money to make money and actually spend some money on hardware, which is the easier one to understand. You know, if you go out and buy an NVIDIA, um, and it looks like all they have are A100s. They don't have any H100s. But in NVIDIA H100, if you go out and buy it yourself, it's going to be $30,000 if you're lucky to get it. And a lot of these are, as AI becomes more sophisticated and developed, they're going to be locked down and not available to just any consumer in the world. So a lot of these aren't even available except to companies like Hugging Face that will rent them out. So even if you did have $30,000 to spare, you might not even have the ability to go out and spend it on one of these. But in this case, these look like they're pretty well accessible. But if you can't get it yourself, you can pay for it. All right, so that's to give your model capability, to give it power, to have it run faster, have it run smarter. But there's also a solution on Hugging Face to have your model be able to be used regardless of how powerful it is. And what that is called is an inference endpoint. It's a infrastructure where your product lives on. So you have various options on the kind of infrastructure you want, where you want your product to live. Various architectures, various providers, um, and then so the architecture um, likely will make the decision on the the Spaces hardware. Um, I'm just a little confused by this because I'm not sure if you have to buy two or if you have to buy one and the other, or if you like one like buying the inference endpoint automatically gives you the Spaces hardware. Because and the reason I'm confused is because if we click into inference endpoints, we can see the architecture column matches the choices you get for the Spaces hardware. So we've got one for NVIDIA A100, which is here. We've got one for NVIDIA T4, which is here. Oh, so we got L4, we got T4. So I guess I'm confused if you do have to buy them separately or if one comes with the other. So I'm going to click Learn More. Okay, so yeah, this is an inference endpoint is uh, basically having your model posted up on here. So yeah, I'm pretty sure you do have to buy both of them. You have to create an inference endpoint um, where you can access the model, and then, well, interesting. Actually, I don't think that's the case. I think, oh, and I heard okay, I heard a noise, but I know what that noise is. The noise is fine. Sound check is good. So now I understand. The reason both of these exist. Okay, so this is a Spaces hardware. So these are Spaces versus inference. So there's a difference between Spaces and inference endpoints. So here's a space. So a Hugging Face space um, is a place where you can build, host, and share your apps. Um, and that's, yeah. So that's different from what um, so if we go to the documentation here, it'll be more clear. Um, so Hugging Face Spaces offer a simple way to host ML, to host demos directly on your profile or organization's profile. This allows you to create your ML profile, showcase your projects at conferences or to stakeholders, and work collaboratively with other people in the ML ecosystem. So, and that's different from an inference endpoint. Let's get the actual documentation for that because that's where it's going to be the most clear. So I should be able to go. Uh, let me duplicate. Yeah, let me duplicate the documentation tab there because this is probably the best bet. And I can even just search the documentation. So I'll do inference endpoint. All right, so got a number of matches here. Go with the first one. There we go. So we can look at the. Anyway, oh, and I'm not logged in. Let me log in. All right. So, so yeah. So, um, let's actually we live in the modern world. Let's take the easiest. Let's take the easy way out here. So, we're gonna take a screenshot of the whole screen, put it into ChatGPT. I've used Model 4.5, um, and then we'll go like this. Take the whole thing here. All right, and then go here. Take this whole screen shot here. All right, and now we're going to ask it questions. So we're going to say, explain to me the difference between Spaces hardware and inference endpoints on Hugging Face. Give me examples of when you would use one or the other, or both. Okay, so Spaces hardware allows you to deploy, yep, on their platform. Okay, so by default you get some juice for it, but you can pay to have more juice. So you'd use this for a demo of something you're trying to build. Just a quick demo. Yeah, and to inference endpoint is something you would use for um, uh, okay, yeah, I think it's fair to say an inference endpoint is something you would use you could use for an actual product. So inference endpoints are a managed infrastructure for deploying models. So that means actually delivering a product that you made that handle inference requests efficiently and scalability. It's used primarily for deploying ML models as APIs that external applications or systems can query programmatically. So let's say that you build a product you're going to sell to someone. We'll call it a happy fun bot that makes people smile. Yeah, you could put that in the spaces, and you could pay to have it juiced. But now people would have to go to Hugging Face to use your Hugging Face spaces to use your product. No good. You want it to be your own product, but you still want it to use to call back to Hugging Face because you get all of these um, uh, I mean, try building this yourself. Like, well, try going on AWS yourself, setting up this architecture and this hourly rate. And honestly, you're like not even rhetorically, like go in and see what the rates are. It's probably a lot of work. It's probably about the same price. So you can have that all set up and ready to go. Uh, and uh, and now you have your own app separate from the Hugging Face platform that uses the services that Hugging Face provides. So that's the difference. So when would you use one or the other? So you would use Spaces for interactive demos and apps. You would use inference endpoints for scalable API inference serving. So if you are outside of the Hugging Face website, you could still use the Hugging Face services if you set up and paid for an inference endpoint. For interaction, you would use Spaces hardware if you wanted just a quick, ready to go user interface, but you would use an inference endpoint if you didn't care about the user interface. In fact, you wanted your own user interface separate from Hugging Face. Then you would use a inference endpoint instead of Spaces hardware because you want it to be API based. You wanted to use to machine to machine communication. You wanted to your app and Hugging Face to talk to each other so that you can use the services offered by Hugging Face. And then yeah, so the cost, you kind of can't decide based on that. It's just how their costs are set up. So if you're using Spaces, they want to keep you on the platform, right? They want you to be involved in Hugging Space. They want the notoriety. They want to grow. They want the word of mouth, good business practices. So they're really going to heavily incentivize you to stay on the platform. So Spaces are often free or low cost. Um, um, and very granular. If you want to give a really sophisticated demo with a lot of horsepower, a lot of juice behind it, you can do that by the hour. So you can just say, for this demo, I'm going to juice it up, and then after that, not. And that can save a lot of money, um, I think is probably what that means. And then inference endpoint, you pay per use. Uh, so yeah, yeah, and there it is right there. The audience. I think that's the main difference. So demonstrations, researchers, collaborators for Spaces, and developers integrating models into products for inference endpoints. So here's an example scenario if you want to use both together. So you're developing a natural language processing sentiment analysis tool. So it's a tool that can process natural language. It can look at text and it can say this text is written by somebody who is sad versus this text is written by somebody who is happy. And you can imagine the person who's sad saying, "Oh, life is terrible. This terrible thing happened to me." The person who's happy say, "Oh, I had this wonderful time this weekend." So you can tell how that is possible, and you might be able to tell why that is useful too. For example, a review system. Let's say somebody's giving 3-star reviews, and it's like, oh, I'm getting bad reviews on this thing. But then you do a sentiment analysis, and everyone loves the product. There's just this small thing that keeps coming up that is why they didn't give it 5 stars. Or even though everyone loves the product, they're just very strict on their ratings, and they'll only give a 5 star if it's like half the price that they expected to pay, or some like bonus thing that made it beyond way beyond their expectations. That's not even possible to practically deliver. All right, so for an inference endpoint, uh, for this sentiment analysis app you developed, you would deploy the model as a scalable inference endpoint API integrated into your company's web app or mobile app, handling thousands of user requests per minute. For Spaces hardware, you'd create a Streamlit or Gradio app demonstrating how your sentiment analysis works, where stakeholders can try out your model interactively without technical setup. This combination leverages each platform's strengths, enabling you to both demo your models. Yeah, okay, well, anyway, give me an example where you would only use one, and then another example where you would only use the other. I think it's starting to become clear, right? So Hugging Face provides you with a one-stop shop, everything you need, um, place you can go to build your products. Now it comes with some limitations. You have to use it on like Hugging Face, for example, but uh, you're set up, you're good to go. It also provides services that you can use for apps that aren't a part of Hugging Face itself. And you can choose to use other providers rather than Hugging Face to get those services. For example, OpenAI itself has the API. So Hugging Face, the inference endpoints are an alternative to to the to this. Yeah, so, well, not exactly. It's an alternative to, man, um, let's stick to the AI because the AI knows, and I kind of don't. So OpenAI has an API. Is that an alternative to Hugging Face inference endpoints, or is it something else entirely? All right, and it has to think on that. I'm not sure. Um, let's try a different, squash that, and then. uh, You try the reasoning model. Huh, it's taking a long time. Oh, there we go. Okay, so so they offer have slightly different purposes and ecosystems. OpenAI API gives you direct access to models via API calls. Hugging Face allow you to deploy your own models or community models on hardware that Hugging Face owns without being locked into Hugging Face through their spaces. So anyway, that's kind of a detour. What I wanted to make this video about was continuing to work on my self-managed network um, and reading this. So I'm going to use yet another alternative to Hugging Face Spaces, inference endpoints, the OpenAI API. The thing I'm going to use is I'm just going to build out my own home infrastructure because I'm a network engineer. I like that stuff. It's fun for me. And this guide here, I think, makes it absolutely clear. Like we're going to get um, a Ubuntu server running, and then we're going to take it and run with it. So uh, right now, my setup is I have one desktop tower running, but we're gonna have at least one more. Well, actually, my setup is I have two desktop towers running. I have my pfSense router, then I have my uh, PC that just it runs my RTX 2060, and it's for everyday use. So we're going to get another desktop running, and it's going to be my inference endpoint, essentially. That's going to be available for me to run models on and to use as an alternative to some of these uh, services on Hugging Face. So when I do the notebooks, I'm going to be, and we can look at if I go to Google Colab, um, so yeah, so I'll be able to do, I'll be able to work through this for free. If we look at my account, um, and we go to billing, we can see my inference usage is depleted. I used 10 cents out of the 10 cents I had. And when you sign up for Hugging Face, you get 10 cents of inference usage for free. But the problem is, as you work through the courses, you're going to run out of inference usage. It's not enough to complete the courses. It's enough to complete about half of one course, um, if that. So you very quickly run out of inference usage. Um, so you need to come up with another um, uh, you need to come up with another. Let me see if I can just create a new. Uh, oh, this is interesting. Well, maybe I can refresh and get my 10 cents back, but I kind of doubt they would allow for that because then you could um, abuse it. But it would be nice if they made it. But we can see here, they allowed me 25 API inference requests. And I need more than that to finish one full course, and I want to finish all the courses they have to offer on there. So I need an alternative than just I want an alternative, and I want to turn that into a learning project too. So that's where this guide comes in. Um, we're gonna set up a my own inference endpoint on my local area network. All right, so let me do a refresh. Actually, let me see. Oops, so for some reason I'm okay. All right, so skip down. So okay, so this is oh right. This page is slow and takes a long time to load and kind of crashes the browser a bit. It's meant to do that. It's just a dump of 13 hours worth of valuable information. So there's really no basis to complain about that because otherwise you just wouldn't get the information you need. So We're going to go follow now the step-by-step installation guide, which is for an Ubuntu server. So, yep, so that's here. So what you should have is two identical SSDs. I have a SanDisk. I have a SanDisk 1 terabyte. Two of them that are the same. Um, so you need two identical SSDs. Mine are SSDs. Bigger is better. We can see the example is only 250, so mine's 4 times bigger than that. So that should be good enough. The bigger they are, the more expensive they are. So I want to keep my costs low. And in addition to that, when I was given uh, free gear from my friends and neighbors, and like it's it's I actually was able to get this set up for half off essentially because I already had one of the discs. So let's take a look quick at the discs that I'll be using for the project. Oh, and my keyboard stopped working. I don't know why it does that. I need to get that fixed. Yeah, keyboard stopped working. It's not out of batteries, I know that's for sure. It's some sort of something is not allowing it to work. Uh, well, the keyboard's not working. Okay, so we'll just read this and then come back and hopefully the keyboard will work later. So we need two identical SSDs as big as possible. I have 1 terabyte SSDs. We need a USB drive to put the Ubuntu installation device on. I have that. We need an old computer to use as a server. It doesn't have to be fancy or sophisticated. A 10-year-old desktop or laptop can work. I have two of them. I can choose between one or the other. I'll make that determination soon. That determination will be based on a number of things. Probably the main thing it'll be based on is how quiet does the tower run, and then in addition to that, it will be um, can I actually use it? Like, what kind of motherboard is it? Does it allow for me to use it as a server? Okay, so the first step is to prepare the installation disk. So, warning, this process will erase everything on the USB drive. So we need to get a USB drive of at least 4 GB in size. We need to put that on my computer. Um, And then we need to go to ubuntu.com, download the long-term support version of Ubuntu server. So long-term support means they're still releasing updates. If it comes up tomorrow that there's a huge security vulnerability and and your computer can be completely hijacked, um, they're still supporting that version of Ubuntu server. So they'll release an update and you'll be able to you'll be able to be protected against that attack. If you use a different version of Ubuntu, one without long-term support, that's it. They're done developing it. If there's exploitations and vulnerabilities, you won't be. There's no way you can be protected unless you write in the an update yourself. Okay, so use one of the following methods to write the Ubuntu image to the USB drive. So Windows, number one, download and install Rufus. So I'll have that already from a prior step. Open Rufus and select your drive. So I'll do that right now. Oh, this is interesting. I thought I had Rufus. I guess I don't. So you're gonna have to install that. That's okay. All right, so I have um, so let's do the X 86 version. That's what I have. And if you don't know the version, you can look that up. You can ask ChatGPT how to look it up. I think an easy way is to go to properties. Uh, that shows my drives. Yeah, these are the properties of the drive, so that wouldn't be the place to look. You'd want to look at it. Yeah, like under this PC is probably where it is. So yeah, so this PC opens up the settings tab. So if we click system, we'll likely find it under there. Oh, and it's frozen again. Don't know why that happens. It's very annoying. Okay, so there we go. So now we made it to system about. So we can see I've got X64. Okay, so it doesn't say X86. So let's hmm. Well, this version is working. I think hmm. Yeah, maybe this version is would be better. I guess I'm not sure. Well, this is the modern world, so let's clarify with ChatGPT. So take a screenshot. There we go. Go into ChatGPT. Okay, so we can see a table that says link, type, platform size, and date. So these are download links to get RUFUS installed. So we can also see my system information. So based on that, which one of the four links should I use? And tell me why. Yeah, so the first one. Okay, so let's see what happens. Yeah, so I downloaded the wrong one. So we'll let this. Okay. Okay, so I downloaded the wrong one. I was confused and I thought I had an X86 without looking it up. So the interesting thing though is that it downloaded successfully. It seemed to have installed and I have it up and running. So like what are the consequences of going ahead and using the X86 even though it seems pretty clear that it's the wrong version for my computer? Okay, so it's just not gonna run as well. But it doesn't matter because it's gonna run fine anyway. So it might go quite a bit faster. So that's a good enough reason for me to get it right because I don't want to be sitting and waiting for an extra, however long for it to complete when I could have just downloaded the correct one and had it gone faster. So that's what I'm gonna do. All right, so now we need to select the device, but before I do that, I have to actually dig up the device. It should be right here on the desk, but the desk is a bit messy. Alright, so I know what I'm looking for, I just don't know where it is. I do have a 4 terabyte drive sitting here, but that drive is not. I have a dedicated drive for this that I'd rather use instead. All right, and I'm pretty sure that drive is somewhere on my desk. I took a look in the other room and it wasn't there. Yeah, so it's somewhere near my desk. Well, can't find the can't find the drive. So can't really do anything until I find that. Well, I mean, I could use another drive. So, well, for the sake of progress, let me do that. So I'm gonna format this entire whopping uh, thumb drive here, which I wish I didn't have to do. There's probably still a way. There's probably a way to find my other one. So let's see here. All right, well, not sure where that other drive is. Without it, I can't continue. Um, all right, so I guess I'm gonna have to end the video now and come back when I find that other drive. It should be pretty easy to find, but uh, oh, found it. Perfect. Okay, excellent. found the drive. So now I just need, okay, so I can continue the video. So plug the drive in. All right. Now I can select it in Rufus, the correct version of Rufus. So there we go. That's the E drive, 32 gigabytes, perfect size. Um, so next step in the guide. Oh, so the guide repositioned itself there. Yeah, and the guide is what is causing this issue with things running slowly. But that's okay. I'd rather have the good information than a website that has bad information but runs very smoothly. So, yep, so there we go. Now we're gonna click select button and choose the unzipped image file that you downloaded. So I skipped that step, so let's go back and download the LTS version of Ubuntu Server. So here it is. All right, and let's put it on the D drive because that is a bigger drive. And typically, images like for operating systems are pretty large. So there is, if you have a smaller drive, there is risk of not having enough space to download the image. And then when you're done using the image, like for example, creating this bootable drive, I do recommend going back to where you downloaded it and deleting that image because it's gonna just sit there and hog up space on your system unnecessarily. All right, but looks like things are going pretty fast. I have blazing fast internet, uh, so it works well for me. Keyboard doesn't work. Oh, speed, yeah, speed test. Yeah, so now the download has finished. So now I can select the image. Okay, so we're going to go with a ISO image, and then we're going to click select there. Perfect. And go to the D drive, and here it is. All right, and I'll run a speed test while it's going just to prove how awesome my internet is. Okay, so now it's ready to be formatted. So I have a feeling that's going to be the next step. So yep, now we click start and create the bootable USB. Um, okay, and we do see a something we didn't see before. It looks like I didn't select a yeah, so it looks like it can be either or. We're gonna go with uh, let's see here. So we're gonna go with ISO because we can see .iso is in the example for the other one, and I'm not sure that it matters. Oh, well, let's see what they recommend. So this image you have selected is a hybrid image. It means it could be written in either ISO or DD mode. Ruffius recommends using ISO image mode, so you always have full access to the drive after writing it. Um, yeah, so I'm going to use the recommended mode. So all data will be destroyed. That's okay. This drive is specifically for booting up operating systems. Um, yeah, so I don't know what's on this drive now. I could look, but I I I doubt I would put anything critically important on this drive because this is my I would put that on a bigger drive. All right. So okay, so now um we'll have this ready for use. We can see a progress bar here. This is actually going to take a while. And then the next step will be to boot from the USB drive. So this is one where I'll have to get out like a camera and show that. Um, and I'll have to plug in a keyboard and temporary monitor. And then I have to make that determination for which tower I want to use. It's definitely going to be based on the motherboard that the towers have, but if all things are equal, it'll be based on how quietly does it run. So let's get the link here to this section. So boot from, uh, let's see here. So boot from, uh, yep. So here's the link to this direct section. Um, and then oh, what happened to my upload? I used to get good upload. Okay, yeah, upload's good. All right, so that's going to be the end of this video, part 11 in the self managed network. Part 12, I'm gonna have to, and as I said, this series I kind of informally marked as ending, even though I did say I would give some updates and kind of come back and do things as I saw necessary to put out. But I won't show everything in this series because I am setting up the particulars of my home network, which includes some things that are really important to keep secret, like passwords and addresses to like DNS resolving systems. Uh, so so this series is just kind of be on and off as it comes, and I'm not gonna show everything. So with that, that's gonna be the end of this video. I'll post it as part 10 to this, and I'll keep work going on this series, but only for what I feel comfortable sharing publicly. So thanks for watching, and see you in the next one.